Hi everyone, my name is Anjana and I'm a graduate student at the University of Virginia. And in this short video, I am going to introduce you an essential building block of Internet of Things. What I'm going to talk to you about today is called a wake-up receiver. It's actually a remote-controlled wake-up alarm circuit that simply turns wireless sensor nodes on and off. But before I get to that, let's try to refresh what we know about Internet of Things. Let's talk about Internet of Things. We live in a world that is massively interconnected with lots of smartphones, smart TVs, smart fridges, smart cars, and tons of other things to make our everyday life easier. So what is this Internet of Things that everybody is talking about? Well, Internet of Things, or in short IoT, is nothing other than expanding this already massive connectivity to pretty much everything around us. Think about if every single piece of equipment in your house is connected to your home network. By the time you get up from the bed, the connected network can tell your coffee maker to prepare your morning pickup drink. And depending on the weather and your preferences, your bathroom can predict how hot the water should be so that you don't waste electricity. The sensors in your garden soil or the houseplants will tell exactly how much you need to water the plants or to add fertilizer. Now these are just a few examples of the ways how IoT can make your life so much more easier and convenient. Another side of IoT that we do not think more often about is how much of a productivity increase it will bring to your workplace. Think of a massive farm where the sensors are telling exact pH levels of the soil and the percentage of each chemicals that are present. Or in an industrial cheese factory where sensors continuously monitor the temperature and humidity along the production lines. So this not only saves a lot of money, it also helps the planet by reducing waste and saving a lot of power. Key components of IoT include real-time analytics, machine learning, sensors, embedded systems, wireless sensor networks, automation. Now these things working together, actually makes up the bulk of the IoT. Okay, let's take a look at the connectivity side of IoT. Wireless connectivity is an essential piece that's needed to make the IoT a reality. Each of these distributed sensors that make up IoT need to be connected to a central access point, like a router or your smartphone, so that the data they collect can be shared or to receive new instructions from the users. But one thing we need to remember that in most IoT networks, these sensors don't need to be on all the time because we don't need this data all the time. So most of the times, we can actually turn the sensors off. Or we call this the sleep mode of components. So in the sleep mode, all these nodes draw very minuscule amount of power compared to their wake modes when they're actually sensing. And thereby we can save a lot of overall power. Since we don't need all the sensors to be awake all the time, we need a way to turn them off and only wake them up when we need them. But how do we do this? Well, one of the simplest ways is to actually for someone to walk to every single node and turn them off and then turn them on when we need them. But imagine doing this every single day, 3 to 4 times for hundreds of different nodes. That would make it very difficult for the users. So instead, we can actually turn them on or off through a wireless network using something like Wi-Fi or Bluetooth or whatever the method we're using to talk to these sensors. But this means we need to keep our Wi-Fi or Bluetooth radio in our sensor node always on. This is not very desirable because it actually turns out that Wi-Fi or Bluetooth radios consume a lot of power when they're on. It can be hundreds of milliwatts. Sometimes the power of these radios are actually higher than everything else in the sensor node. Now we have a problem, so how do we get around this? Well, this is where a special type of radio called a wake-up receiver becomes very useful. Unlike the regular data receiver that needs to operate with high data rates and high performance, a wake-up receiver can be implemented to be a very simple radio with a low power that is only made to listen to a simple wake-up call. Now you get the idea. We keep all the other components in the sensor node in a sleep state where they're drawing minuscule amount of power, where the wake-up receiver is the only always-on component. And then, when this wake-up receiver hears the wake-up command, it can turn on the node and start sensing and then transmitting this data back. So in a way, a wake-up receiver acts like a wireless switch, but this switch has to be really low power to make sure we aren't wasting any unnecessary power in our node. So now we know about a very important piece of hardware that enables power-efficient and eco-friendly IoT networks. The actual work that goes into designing one of these wake-up receivers can actually be very interesting and a fun thing to work on. There are lots of circuit techniques we have to use both in analog and digital domain. So if you're excited about communication and wireless connectivity, wake-up receivers can be a very cool topic to look into. Here at University of Virginia, our researchers have contributed several state-of-the-art wake-up receivers, and here is one such example. The prototype fabricated wake-up receiver is in the middle of this golden rectangle, and we're using this PCB to evaluate and characterize the wake-up receiver. And now this particular wake-up receiver operates at 433 MHz band, and it can communicate up to about 10 kilometers, and it only consumes 33 nanowatt of power. I hope you enjoyed watching this video and learned something valuable. This video is part of Solid State Circuit Society video contest, and if you have time and if you're excited about electronic circuits like I am, please check out the other submissions and you will get to learn about many other interesting components and circuits. Thank you very much.